Hello everyone. Welcome back to JEE Physics PYQs. Today's problem is from JEE Main 2019 and it is an excellent application of the Work-Energy Theorem involving a variable retarding force. Many students immediately try to use equations of motion here, but that doesn't work because the force is not constant. Let us see the smartest JEE approach. A block of mass 1 kg moves with speed 10 meter per second along the x-axis. It enters a rough region extending from x equals 0.1 meter to x equals 1.9 meter. Inside the region, the retarding force is Fr equals minus kx, where k is 10 Newton per meter. We need to find the final speed of the block as it leaves the rough region. Pause the video here. Remember, the force depends on position, so think carefully before writing equations. We will solve it together in 3, 2, 1. Solution begins. Since the force varies with position, the earliest method is the work-energy theorem. Recall W equals delta K. That means work done by the retarding force equals final kinetic energy minus initial kinetic energy. Initial kinetic energy is, we have mass m equals 1 kg, initial speed u equals 10 meter per second. Therefore, initial kinetic energy Ki will be half mv square, which equals half into 1 into 10 square, 50 joule. So the block initially possesses 50 joules of kinetic energy. Next, work done by variable force. The force is F equals minus kx. Since it varies with x, work is obtained using the integration. W equals integral f dx from 0.1 to 1.9. Substitute the force integral minus 10x dx from 0.1 to 1.9. W equals minus 10 integral x dx from 0.1 to 1.9 minus 10 into x square by 2 from 0.1 to 1.9 minus 10 into 1.9 square minus 0.1 square. W will be minus 5 into 1.9 square is 3.61 minus 0.1 square 0.01 minus 5 into 3.60. W will be minus 18 joule. Notice the negative sign. The force opposes motion, so it removes 18 joules of kinetic energy. Now, final kinetic energy using W equals delta K minus 18 equals final kinetic energy Kf minus 50. Therefore, final kinetic energy Kf will be 50 minus 18, 32 joule. Now let us find final speed. Kf equals half mv square. 32 equals half into 1 v square. V square will be 64. V will be 8 meter per second. Hence, the correct answer is D, 8 meter per second. Now, JEE shortcut. Here is a quick shortcut for such questions. Whenever the force is given as a function of position, don't think of acceleration. Instead, directly remember W equals integral f dx. Then apply final kinetic energy Kf equals initial kinetic energy Ki plus W. This method is faster, cleaner, and avoids unnecessary calculations. Common mistakes. Students often make 3 mistakes. First, using v square equals u square plus 2as. This equation is valid only when acceleration is constant. Here, force changes with position, so acceleration also changes. Second, forgetting the negative sign in F equals minus kx. The force removes energy, so work must be negative. Third, integrating from 0 to 1.9 meter. Remember, the force acts only inside the rough region from 0.1 meter to 1.9 meter. Choosing the wrong limits changes the answer completely. Exam tip: whenever you see force depends on X, spring force, variable resistance, electric force varying with distance, immediately think integration plus work energy theorem. This is the favorite approach in JEE Main PYQ Insight. This problem beautifully combines variable force, integration, and work energy theorem. Once you master this pattern, you will be able to solve many JEE Main and advanced questions involving variable forces with confidence. If this solution made the concept crystal clear, give the video a like and share it with your friends preparing for JEE Main 2027. Subscribe to JEE Physics PYQs for carefully selected official previous year questions with quick exam-oriented solutions. Thank you for watching, and I'll see you in the next PYQ.